Hello everyone, welcome to our class on differentiation calculus. Differentiation is the process of finding the derivative of a function. So suppose we have that y is a function of x. Now, if there is an increment in x, it will result to an increment in y. If there is a change in x, there will be a corresponding change in y. For example, suppose you have a product that was sold, let's say a product that was sold at $10, and suddenly the price increased to $15. You will notice that people would want to subscribe to an alternative commodity that has a comparatively lower cost relative to the first cost case. So because of the change in the price of that commodity, there has been a change in the quantity of that commodity demanded in the market, because people would ordinarily want to buy a cheaper commodity. So the change in price has affected the quantity demanded. That is why in general economic terms we say that the higher the price, the lower the quantity demanded. So that's the concept of differentiation. So how does a change in a quantity, in a parameter, affect the other parameter that depends on it? So like we say, if y equal to f of x, and there is an increment in x, let's say delta x, it could be a very small increment. What will happen to y? So if we say that delta x has been added to x, automatically there will be a change in y, which is delta y. Of course, we are not going to write delta x because y will still respond based on its own situation. But what is more important is that the change in that quantity, let's say the price, has affected the quantity demanded in its own way. So if we decide to make this delta y the subject of the formula, we have f of x plus delta x minus y. So what it means is that our delta y is equal to f of x plus delta x minus f of x, because our y is also f of x. So suppose we divide both sides by delta x, we have f of x plus delta x minus f of x all over delta x. So notice that delta y over delta x is the slope along the interval, slope or gradient along the interval delta x, or which we also call the difference quotient. The difference quotient. If we should bring down this interval as delta x tends to 0, that means we are now able to obtain the derivative of the function y with respect to x. We have to illustrate it diagrammatically. We also have to take an example. And in that case illustrate further. So we are asked to differentiate x power 4 plus x power 2 using the first principle. But before we start, I would like to emphasize something regarding the use of this expression f of x plus x over delta x, which can also be written as f of x plus h minus f of x all over h. The use of delta x and the h are still just an increment in x. So given we have a curve like this, at this point a, which is say x, and we have f of x, where f of x is our y. Remember, our y is f of x. So, and here, and we decide, let's say that at this point, this is point x1, which if we have here as our x. Now this x decides to make a change. There is an increment in x, say delta x. So at a point, another point, let's say point B, delta x. So such that the overall length now becomes x plus delta x. So at this point, our x length is x plus delta x, and our y will now be the function of that x plus delta x. So you see that the slope of this curve at point A is obtained by taking a line that touches, taking the slope of a line that touches that point, which we call the tangent to the curve at that point. So you see, if we take the slope of this curve, we have this, so such that we say delta y over delta x is equal to, you see this is flatter, but for this one, if we take the slope of this point, you see this is steeper. If we want to find the slope at this point, we have to, you see, for this point B, a small increment in x has a higher change in y, has a higher increment in y, because the slope is steeper, unlike this. So for a curve, the slope is not the same, it's varying. It has a constantly changing slope. So for a curve, the slope is constantly changing, unlike a normal linear graph where the slope is the same everywhere. So now for this case, we can obtain the slope between this point A and B by drawing a straight line joining A and B, so that when we take the slope, we can say that delta y over delta x is equal to y2 minus y1 all over x2 minus x1. But this is just a mere approximation, because this line is not exactly along, this straight line is not exactly along the curve. So if we must have to obtain the actual slope, we have to take it at a point on the line, on this curve. And we can do that by reducing this delta x, shrinking it to get to the point A. By that time, we have taken the slope, the limit, as delta x tends to 0. And that's our derivative. But meanwhile, our delta y over delta x is now our slope along the curve, which is also called the difference quotient. So this is the same thing as f of x plus delta x minus f of x all over x plus delta x minus x. This is the same thing as, so this is the slope along this interval. This is the slope along this interval. So we say the slope, this is the slope along the interval of delta x, which we call the difference quotient. So now, because this slope along this interval is changing, we need to focus on a particular point, let's say point A, whereby the slope is instantaneously constant, which we call the instantaneous slope, and that is our derivative. So, and how do we do this? We can only do this by bringing these points down to A. Now, let us begin to reduce this down to A. So, as we bring down this point, this delta x is shrinking, is approaching x1, is approaching this point x1. So, as it is approaching this x1, this point is reducing. So, if we get to this point where this delta x becomes 0 or approaches 0, let's say exactly at this point A, so that is the limit it can approach. As this delta x approaches 0, it means that x2 is overlapping now with x1, and that is where we say that that is the derivative. That's where we have the derivative. So the derivative of this point, which we now write dy dx, is the limit of this difference quotient as delta. Go back to our y equal to x power 4 plus x squared. So how do we differentiate this? Using the first principle. Let's use our delta y over delta x is equal to, which is our difference quotient, f of x plus delta x minus all over delta x. Our f of x is equal to x power 4 plus x squared. So what of our f of x plus delta x? What of if there is a change in x, an increment in x, delta x? So this will now become, anywhere we have our x, we replace it with x plus delta x. So this is x plus delta x raised to power 4 plus x plus delta x all squared. So if we expand this, we can expand this using Pascal's triangle. So for this power, we are going to use this expression. The first one goes with 1, so which is 1 times x power 4 dot delta x power 0. Also our x plus delta x squared. So in our differentiation, we have that delta y over delta x is equal to is minus. So we have x power 4 plus 4x power 3 delta x plus 6x squared delta x squared plus 4x delta x power 3 plus delta x power 4 minus x squared, x power 4 plus x squared all over delta x. So this and this goes, this and this goes. So we have 4x cubed delta x plus 6x squared delta x squared plus 4x delta x cubed plus delta x power 4 plus 2x delta x plus delta x squared all over. That's the slope along the interval delta x. If this divides this, we have 4x power 3 plus this divides this, we have 6x squared delta x plus 4x delta x squared plus delta x power 3 plus 2x plus delta x. So our derivative now at a point where delta x is 0, which is the instantaneous gradient or the instantaneous slope, will now be when we take the limit of this as delta x tends to 0, and that will be giving us 4x power 3 plus 6x squared times 0 plus 4x times 0 squared plus 0 power 3 plus 2x plus 0. So our dy dx at a point is now 4x power 3 plus 2x. Suppose we want to interpret this result with this. So we can say that we must have obtained this by, if we multiply this 4 with the coefficient of x here, that is 1. 4 times 1 is 4. Then we have our x, and subtracting 1 from this power is the same thing as 4x. 4 minus 1 is 3. So 4x power 3. Then as for this, we have, if we still repeat the same and say 2 times the coefficient, which is 2,
Then we have our x, 2 minus 1, which is 1. So this is 4x power 3 plus 2x, because x raised to the power of 1 is x. So 2 times x is 2x. So we have this, and this is the same thing as this. So what it means is that if we have x power n, that the derivative of x power n will give us multiplying n with the coefficient of x here, which is the coefficient of x here is 1, n times 1 is n. Then you have our x, then you subtract 1 from n, then n minus 1. So this formula can also be derived using the first principle. Therefore, we can say that the derivative of a function, say x power n, is the same thing as nx raised to the power of n minus 1. So assuming you are asked to find the derivative of x power 8, this is the same thing as 8 times 1, 8. Then you have x power 8 minus 1, 7. Then the derivative of 2x power minus 3, this is the same thing as minus 3 times 2, minus 6. Then you have x minus 3 minus 1, minus 4. So this is minus 6x raised to the power of minus 4. So this will be the basis of our subsequent example using the second principle.